Hey guys, this is Akshay and welcome back to my channel, which is Science with Sam. So today we'll be doing the question answer session based on the videos that I posted before. So let's just do the questions one by one. The first question says, draw the structures of the following compounds. So the first compound is cyclopropane. So as I mentioned before, aliphatic compounds need not always be just a linear chain. It can be a cyclic chain also. So all the cyclic aliphatic compounds are represented by the word cyclo and followed by the respective alkane, alkene or an alkyne. So the first one says cyclopropane. So from this we come to know that 1, this is a cyclic compound, 2, it has totally 3 carbon atoms, and the third fact is that it has a single bond. So a compound which is cyclic and which has 3 carbon atoms is represented by a triangle. So it is just a triangle, and next it says it's propane. That means it's just a single bond. So because of which you don't have to draw any bonds here. So for all the cyclic compounds with a certain number of carbon atoms, you need to represent that with the help of the geometrical figures. Like for instance, in case if this is cyclopentane, that means you will have to draw a pentagon which has totally 5 sides, and you don't have to include any additional bonds because it is pentane. That means it's just a single bond. So let's go on with the next one, which says a benzene derivative having an alkyl group. That means it can be toluene, because toluene is the one which has a CH3 group, which is a methyl group, and this methyl group has been derived from the alkane, which is known as methane. So you draw a benzene structure which is nothing but a 6-sided figure, and then you have to draw this, which is nothing but the ring. And I've already mentioned in the previous videos why there is a circle and not lines like this. Instead of lines like that, you would just represent it by a circle, and I've mentioned it why you need represented by a circle. So and now since it says a benzene derivative having an alkyl group, you basically attach an alkyl group. So it can be either CH3, so it will be toluene, or it can be C2H5, C3H7, it can be any alkyl group. If they mention you're supposed to draw the structure of toluene, then it should always be CH3. So the next one says cyclohexane. So now it's a cyclic compound, and the next one says it is a 6 carbon structure. So a geometrical you need to draw a geometrical figure such that there are totally 6 sides. So it should be something similar to your benzene structure, but you should not draw the ring. The ring, which is nothing but the circle in between, is an exclusive figure just for your benzene structures. So for this, let's draw a structure similar to your benzene ring, and you're not supposed to draw this circle because it is just for your benzene. Since it's hexane, it's an aliphatic compound. And now it says ine, that means there's a triple bond. So you can choose any of the positions and include 2 more bonds like this, because 1 bond is already present and you need to include 2 more bonds to make it a triple bond. So why I can draw the same 2 bonds here, here or here, because you can start counting the first carbon atom from any position. The reason behind this fact is that there is no minor substituent. If there is a minor substituent, then you need to consider that respective carbon to which the minor substituent is attached as the first carbon. Here there is no minor substituent, so you can take any of it as the first carbon, and you can include 2 bonds so that it becomes hexane. So that's how you need to that's how you draw the structure of cyclohexane. So next structure says, the name of the structure is 2,2-diethyl 3-methyl pentane. So that means N-pentane is a normal form of pentane which does not have any substituents, which just has hydrogen. And when this hydrogen atom has been substituted by any minor substituent or a major functional group, it becomes a substituted form of a pentane. So 2,2-diethyl 3-methyl pentane is nothing but a substituted form of a normal pentane. So first let's just draw the normal form of pentane, and then we'll include the diethyl and methyl. So it will be CH3, CH2, 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 and then CH3. So it will be CH3, CH2, 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 CH3. So there are totally 5 carbons, and the tetravalency of every carbon has been satisfied with the help of hydrogen atoms. Now you're supposed to replace 2 ethyl groups in the second carbon position. That means this is the second carbon, there are 2 hydrogen atoms before. You need to replace the 2 hydrogen atoms with the help of 2 ethyl groups. So rub the hydrogen, and then you write C2H5 and then C2H5. So you write C2H5 in the place of the hydrogens in the second carbon atom, and it says 3-methyl. So for 3-methyl, go to the third carbon atom, take off one hydrogen and replace it with a methyl group. So now let's start off with the structures of these compounds. So now the first compound says 2-chloro-5-ethyl heptane. So now from heptane we come to know that the number of carbon atoms is supposed to be 7. And then the second part, which is nothing but your suffix, it says it's ane. That means there's only a single bond. And then the hydrogen of the second carbon atom and the hydrogen of the fifth carbon atom has been replaced by a chlorine and an ethyl group. So chlorine is supposed to be a halogen and ethyl is supposed to be an alkyl group. So now let's draw the structure. First let's draw without the substituents, and then we'll include the substituents. So it will be CH3, CH2, 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 CH2. So it will be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then 6 CH2, 7 CH3. So that is heptane. So and then afterwards you replace the hydrogen atom in the second carbon atom by chlorine. So it will be CH, Cl, and 5-ethyl. So that means go to the fifth carbon atom, replace one hydrogen, write it, substitute it with ethyl. So this is how you draw this structure. So next one says 3-bromo-butane-1-al. So generally you can write butan-1-al as butanal also, because you don't have to mention the number in which the aldehyde group is present if it is present in the first carbon atom itself. Sometimes just to give questions like this, they might change the number as 2 or 3. So in that case, mentioning the number is very, very important. So now we'll draw the structure on the basis of whatever is given here. Since it's butan-1-al, the very first carbon atom, whether from the left to right or from right to left, should have the aldehyde group. And one more thing that I've told you is the carbon atom in the aldehyde group is also considered as a carbon atom in the whole parent chain. So since it says butan-1-al, you need to write only 3 carbon atoms apart from the carbon atom present in the aldehyde group. So you write, first let's write without the substituent. So it will be CH3, CH2, CH2 and CHO. This is how you write butanal. And now you should write 3-bromo-butanal. So for 3-bromo-butanal, you need to substitute the hydrogen atom present in the third carbon atom with a bromine group. So that's how you're supposed to write. So now the next one says acetone, and then after that says acetaldehyde. So I'm sure you must have not heard these names under the IUPAC nomenclature. The reason behind this fact is that these two are known as the common names. These two common names are often tested because they are each and every compound in organic chemistry will have an IUPAC name and then a common name. But the common name acetone and the common name acetaldehyde is often tested. So now if they tell you to draw the structure of this, then you will have to know what the IUPAC name is, so it will be easier for you to name. So draw the structure. So acetone is nothing but the IUPAC name of the compound acetone is propanone. So and then you know, in case when there is one, that means it is nothing but a ketone. And also you know the fact that the carbon in the ketone group is also considered as a carbon in the parent chain. So you write CH3 C double bond O CH3 as a structure of acetone. I'll repeat, acetone is nothing but a common name for the structure propanone, because propanone is nothing but an IUPAC name, acetone is its respective common name. So propanone, which has a ketone group, should have totally 3 carbon atoms, and apart from that there should be a double bond and then oxygen also must be there. So that means the structure of acetone or propanone is complete. Next one says acetaldehyde. So now in the previous question for acetone I said there are only 3 carbon atoms, so we will draw the structure of propanone, but it doesn't mean that acetaldehyde will also have 3 carbon atoms and then it will be the respective aldehydic form. Acetaldehyde is supposed to be an aldehyde which has totally 2 carbon atoms. So you know that CHO is the way in which you represent an aldehydic group, And then since acetaldehyde is supposed to be an aldehyde with totally 2 carbon atoms, you need to add one more alkyl group such that it has only 1 carbon atom. So you write CH3, because any functional group will have its respective representing structure. So what do you mean by representing structure? So CHO is the one which represents the structure of an aldehyde group, while OH is a representing structure of the respective alcohol group. So you need to add that and then you attach that to an alkyl group. So in case if the representing structure of the functional group has a carbon atom, then you choose an alkyl group such that it has certain number of carbon atoms so that you satisfy the question given to you. So the next one says pentanoic acid. Again, COOH has a carbon atom. So you choose 4 carbon atoms plus the COOH group and your structure is over. So let's write. So CH3, CH2, CH2, CH2 and then COOH. So this is H. Here for instance you have the compound CH3, CH3, that means the hydrogen atoms of the second carbon atom has been replaced, and then you have one more CH3 group, and then this is supposed to be a 3 carbon compound, and then the CH3 is present in the central carbon atom. So since the number of carbon atoms is odd and then CH3 is present in the central carbon atom, numbering it in any way is not a problem. So you number it like this: 1, 2 and 3. So now you name. You should write 2, 2 dimethyl, 2, 2 dimethyl propane. So and then first you will be knowing why it is 2, 2. That means both the methyl groups are present in the second carbon atom. So that's why 2, 2. And it's dimethyl because 2 methyl groups are present in the second carbon atom. So 2, 2 dimethyl, and then there is propane. So that's how you draw the structure for the first compound which is given. So second compound says CH3C, the CH3 single bond C, triple bond C, and then single bond CH2, single bond CH3. So first when you check, the tetravalency will be satisfied. That is the reason why then there is no hydrogen atom here, because 1 bond is here and 3 bonds are on the other side. So tetravalency has been satisfied for this carbon as well as this carbon. So and here you don't have any other substituent also. So the only minor functional group is nothing but the triple bond. So you need a number in such a way that this triple bond gets the least number. So let's start numbering from this side, which is from left to right. So it will be 1, 2, 3, 4 and 5. If you number from this side, it will be 1, 2, 3, 4 and 5. So there is not a problem here, because whatever way in which you number, you will be getting only the same pair of numbers. So now from 2 and 3, choose the smallest number. So the smallest number is 2. So you can write it as, and then apart from that, you are supposed to note down the number of carbon atoms also. Here the number of carbon atoms will be 1, 2, 3, 4 and 5. So you should write it as pent-2-ine. But sometimes in few books or in your textbook itself, the name will be pent-2-pentine. This is also fine. Pent-2-ine is also fine. Whatever it is, the naming will be accepted. But what I prefer is this one. I always prefer pent-2-ine because it will be easier. It will be easier for you to identify that yes, the triple bond is present between the second and third carbon atom. That is why you have selected a number 2. Because you can write as 2-butanal or 2-pentanal or pent-2-al. You can write in any way. But in this case, I always prefer the number 2 to be written in between. So that's all you need to do for this part. So the next one says CH3, CH and then CH3, CH2, CH2, COOH. So for this you need to number in such a way that this carbon gets the lowest number. That means the highest preference, in the sense the lowest number must be got. So you write 1, 2, 3, 4 and then 5. So this is how you are supposed to number. So and then the carbon in the COH gets the least number, and then afterwards the rest of the substituents will be getting the respective numbers. So we have numbered it. So now let's write. So this normally while explaining the major rules of IUPAC nomenclature, I would have explained about the importance of prefix. Prefix is the one which has the number and then the respective substituent. Number in the sense number of the carbon atom and the respective substituent where it is attached to. So here this minor substituent is CH3 and then the number is 4. That means you are supposed to write 4-methyl 1, 2, 3, 4, 5. That means 4-methyl pentanoic acid. You suppose to write 4-methyl pentanoic acid, because the reason why it's pentanoic is there are totally 5 carbon atoms including the carbon atom COH, and then it's an acid group. So that means you need to add the suffix oic acid, and the prefix must be 4-methyl because prefix must generally have the number of the carbon atom and then the name of the substituent group. So next one says CH2Cl, CH2, CH2CO, CH3. So here you need a number in such a way that the carbon in the ketone group must get the lowest number, that means highest preference or the lowest number. So you number from this, obviously the carbon in the ketone group will get the very high or bigger number. So because of which you number from the right side. So it will be 1, 2, 3, 4 and 5. And next comes your prefix. Your prefix in the sense you need to find what the minor substituent is. The minor substituent is chlorine and then it is attached to the 5th carbon atom. So you write 5-chloro. So prefix is done, and next you go to the root word. Root word means number of carbon atoms. Number of carbon atoms will be 1. So I have numbered here. So obviously it's 5 carbon atoms. So it will be pentan, because normally while writing such names you are supposed to cut the E alone of the respective alkane. So here there are totally 5 carbon atoms, so the respective alkane is pentane. When you are introducing a suffix, so let it be for on in the case of ketone or al in the case of CHO, you are supposed to cut the E of the alkane and then introduce a suffix which generally represents the functional group which is present in the compound. So it will be, so as I said, it will be pentane, so but then you need to cut the E. So and then CO group. So CO group means your suffix must be on. So it will be pentanone. See? Yeah. So now let's do the next question, which is nothing but based on isomerism. So normally isomerism based questions will always be a theoretical based question, unlike IUPAC questions. So the first type of question can be based on these facts, which is written in the box in your textbook. So that means based on number of isomers. So in case of the respective compound which has totally 4 carbon atoms, it will have 2 isomers, and you know what the 2 isomers are. One thing is nothing but a normal butane and the second one is nothing but isobutane. If the same compound has totally 5 carbon atoms, that means it has totally 3 isomers. One is a normal form of pentane, other one is isopentane, the third one is nothing but neopentane. And then 6 carbon atoms will have totally 5 isomers, and the names of the isomers are not mentioned and it is not required for you also. And next one, 21 carbon atoms will have totally million isomers. So you can get this in the form of an MCQ or in the form of fill in the blanks. So this is the first type of question. And then the second type of question is based on definitions. So based on definitions, it can be defined a stereoisomer, which is nothing but a geometrical isomer which is based on the position of the respective substituent in the plane. And then next one can be define an isomer or define any other type of isomer. So that is nothing but questions based on definition. So please like, share and subscribe to my channel, and then if you have any other queries regarding my videos, please do leave comments below. Thank you so much.